Okay, to help you get a better understanding of how logarithms work, there is an exercise that you can do where I give you a logarithm and you tell me whether that logarithm is one of three things. So this is multiple choice basically, okay? You should be able to tell me whether a logarithm is less than 0, between 0 and 1, or greater than 1. Here, let me show you what I mean. You already know that if I tell you, hey, what is log base 2 of 8? And you're like, I already know the answer to this, Mr. Ryan, because I know that 2 to the third power equals 8, so I know that log base 2 of 8 is equal to 3. This is a very simple, memorizable, basic logarithm, okay? But we're now going to enter into the realm of logarithms where I give you numbers, where I give you logarithms that are not easy to answer. In fact, for most of these, you would need a calculator to do them. Now, I actually don't want you to do them on a calculator. I want you to learn logarithms so that you just simply understand how they work and how you can break them apart and put them together. So let's say that we have log base 2 of 7. Log base 2 of 7. Well, that means that 2 to some power is equal to 7. Well, we know that 2 to the second power equals 4, and 2 to the third power equals 8. But this 2 to the something power equals 7, you'd have to take a calculator. Here, let me grab a calculator over here, and you would have to just try. We call this trial and error, like 2 to the, I don't know, we know it's between 2 and 3. 2 to the 2.7 power, well, that equals 6.498. Well, how about 2 to the power of 2.8? Well, that equals 6.964. Well, we're getting closer. We're almost at 7. But you can already see that the answer to this is going to be a decimal. It's going to be an ugly, ugly, ugly answer. Okay? Well, instead of asking you to identify the precise value, all I want you to tell me is, approximately what is it between? Well, we know that this is between, it's going to be less than 3, but it's going to be greater than 2. This logarithm is somewhere between 2 and 3 because log base 2 of 4 equals 2 and log base 2 of 8 is equal to 3. So that means that log base 2 of 7 is somewhere between 2 and 3. Well, I don't want to do that right now, the between 2 and 3, although we could do that later. What I want to do right now is really, I want to understand logarithms that fit in one of three places, and I only care about these three places. They're either less than 0, which means they're a negative number, and yes, an exponent can be a negative number. You've already seen this before when we did like x to the negative 3 power. That was the same thing as 1 over x to the third power, right? We can have exponents that are negative. And since exponents can be negative, logarithms can be negative. They can be less than 0, okay? We can also have logarithms that are between 0 and 1, okay? Now we know that because we've seen that we can have a logarithm that is equal to 0. We can also have a logarithm that is equal to 1. And then we've already seen plenty of answers where the logarithm is greater than 1. Well, in order to be able to do this, there's actually a very simple rule to answer this question. It is so simple, okay? For example, we know that log base, let's say log base 5 of 1 is equal to 0, okay? So knowing that when there's a 1 in here, that it's equal to 0, and then we also know that log base 5 of 5 is equal to 1. And so here's what I'm telling you, is that for log base 5, if the argument or if the product that's inside the parentheses here, let's go ahead and do this. Well, let's start with what would happen if the number was less than 1? What if we had log base 5 of, let's say, 0.9? Okay, well, because the argument in here is less than 1, that means that the answer, the exponent, the logarithm, is actually going to be less than log base 5 of 1, which is 0. So it would be less than 0. So we know that this logarithm is less than 0. And so here's the rule. You will always choose less than 0 if the argument is less than 1. Okay? Now this number in here, now don't get confused with something I said before. This number in here has to be a positive number. We can't do logarithms of negative numbers. Logarithms can have an answer. They can have an answer that's negative, but they cannot have an argument or a product that is negative, okay? And so if the argument in here is less than 1, and it also has to be larger than 0, so basically if that number in here is between, it's a decimal, between 0 and 1, then your answer is less than 0. So if we do log base 93 of 0.46, we know that this logarithm is going to be less than 0. And that's how we answer the less than 0. Now let's see how we answer the between, or no, let's go to greater than 1, and then between 0 and 1 will be a piece of cake. Okay, so as far as greater than 1 goes, we know that, let's say log base 8 of 8. We've already learned that if we have the same number as the argument as we have as the base, we know that the logarithm is equal to 1. So how would we get a logarithm that is greater than 1? Well, that's very simple. If the argument inside here is larger than the base, then the logarithm is going to be greater than 1. So if I say, for example, log base 8 of 9, that logarithm will be greater than 1. Okay? So the rule for choosing greater than 1 is if, that's that number right there, if the argument or the product that's in the parentheses, the number that's in the parentheses, if the argument is greater than the base, of the logarithm right here, then the logarithm is greater than 1. Okay? And so a few examples of that would be, let's say that we have log base 2 of 17. 17 is larger than 2, so we would select greater than 1. If we had log base 4 of 9, 9 is greater than 4, therefore this logarithm is greater than 1. So if the number in the parentheses is larger than the base, then it's going to be greater than 1. Well, what about the natural logarithm? Okay, well, I know I introduced the natural logarithm to you. Let's go over here. What if I said, what is the natural logarithm of 0.3? Well, 0.3 is less than 1, and we already said that if this argument is less than 1, then the answer is less than 0. So this logarithm is less than 0, okay? But what if I said, well, what about the natural log of 5? Well, what is the base of the natural logarithm? It's e, which is approximately 2.71, let's say 2.72. Well, 5 is larger than 2.72, and so for this one, we would select greater than 1, okay? And so that's how we select either less than 0 or greater than 1. And now this is going to make it really easy. Now that we know the answers to both of these things, it makes it so easy to know when to select between 0 and 1. Okay, so now that we know how to identify when a logarithm is less than 0 and when a logarithm is greater than 1, all we have to do is look for an argument that's between those things, and that gives us a between 0 and 1. For example, log base 6 of 4, okay? The argument is not larger than 6. Therefore, we're not going to select greater than 1. The argument is not less than 1. Therefore, we're not going to select less than 0. The argument is between 1 and the base. 4 is greater than 1, but less than the base 6. And when that happens, our logarithm, the exponent that goes on the 6, is going to be between 0 and 1. Let's find out exactly what this one is. I have a super special way in this calculator to be able to identify a logarithm, except I went to the wrong thing here. Let's go here. There it is. Log base 6 of 4 actually equals 0.7737. This equals 0.7737, which you can see very clearly is between 0 and 1. And if you grabbed a calculator and you put in 6 to the power of 0.7737, you would get, let's go ahead and do that, 6 to the power of 0.7737, and I get basically 3.9999999, which is, it's basically 4. And so, now you don't have to know how to do that. I was just showing you. I was using it as an example. I'm just helping you understand that the way that we know whether a logarithm is less than 1 but greater than 0 is if the argument, which is the number inside the parentheses, if the argument is greater than 1, it's a number that is larger than 1, okay, but smaller than whatever the base is, smaller than the base of the logarithm, okay? 4 is smaller than 6 and it's greater than 1, therefore we would select between 0 and 1. So let's say we had something like log base 2 of 1.5. Okay, well 1.5 is larger than 1, right? But it's smaller than 2, it's between 1 and 2, and therefore, for this logarithm, whatever the answer is, we don't care what it is, we just want to know, is it less than 0, between 0 and 1, or greater than 1? The answer is between 0 and 1. And so what I want to do now is I want to maybe give you about maybe 4 or 5 examples, and I'm going to let you decide whether each one is less than 0, between 0 and 1, or greater than 1. All right, here's 5 quick examples. Let's do this one first. Log base 4 of 0.7. Well, 0.7 is less than 1, and so that means that this logarithm is going to have a value that is less than 0. Okay? How about log base 7 of 12? Well, 12 is not less than 1, so it's definitely not less than 0, but it is larger than the base. This argument is larger than the base. We know that when the argument is larger than the base, that the logarithm is going to be greater than 1. Okay? This natural log of 1.8, well, remember, natural log has a base of e, which is about 2.72. 1.8 is less than 2.72, but it's larger than 1, and therefore it's not going to be less than 0, it's not going to be greater than 1, it's going to be between 0 and 1. So the natural log of 1.8 is some number that's between 0 and 1. How about this log base 12 of 7? Well, 7 is larger than 1, so it's not going to be less than 0, but it's less than this base of 12, and so again we have the answer between 0 and 1. Last one, this log base 4 of 8. Well, the argument 8 is larger than our base of 4, and therefore this logarithm has to be greater than 1. And that really is how simple these questions are. That's it for being able to answer less than 0, between 0 and 1, or greater than 1.